Tires are often called the soul of movement because they're the only part of a vehicle that actually touches the road. Every year, the world produces around 2.5 billion tires. That's more than 7 times the population of the United States. But have you ever wondered how a tire is actually made? From milky white latex dripping from rubber trees and tropical plantations, to the grip that holds a Formula One car steady in a high-speed turn, every tire is built from dozens of layers, bonded together to withstand heat, pressure, and friction over hundreds of thousands of kilometers. Whether you're driving a 600 horsepower supercar or a regular family sedan, without a good set of tires, all that power means nothing. In this video, we'll take you inside the fascinating process behind this unsung hero, from raw materials to the toughest tests in the industry. A tire is just a thin layer of rubber gripping the asphalt, but it controls everything. How well a car holds a turn, how quickly it can brake, how stable it feels on a sharp curve or a wet road. Behind that seemingly simple piece of rubber is a global industry operating in over 180 countries, with thousands of factories working non-stop to meet the needs of nearly 1.5 billion vehicles on the road. The industry is worth an estimated $320 billion, driving constant demand for natural rubber, steel, and recycled materials. In Formula One racing, a set of tires lasts just 50 to 100 kilometers. Some barely make it through a single lap before being swapped out. A good tire can mean the difference between winning and crashing, between a smooth launch and a dangerous skid. And beyond the racetrack, old tires are being recycled into playgrounds, furniture, and soundproofing materials, showing that their story doesn't end when the ride is over. Before any materials enter the production line, tire design is carefully developed using digital models. Engineers must calculate the cross-sectional shape, ply structure, tread pattern, and rubber composition to achieve the ideal balance between grip, durability, load capacity, and noise reduction. Depending on the intended use, whether for high-performance sports cars, heavy-duty trucks, or everyday passenger vehicles, each type of tire requires a unique design. Every detail is digitally simulated and virtually tested before moving on to the physical manufacturing stage. Before it ever hits the road, a tire's journey begins with a milky white sap slowly dripping from the bark of a rubber tree. This fragile-looking liquid is actually the foundation of one of the toughest, most resilient materials humans have ever engineered. Deep in tropical plantations, skilled workers use sharp blades to make precise cuts along the bark. Each incision must go just deep enough to reach the latex channels, but not so deep as to damage the wood underneath. If cut too far, the tree stops producing sap and can die within weeks. Drop by drop, the white latex falls into small cups fixed to the tree, slowly, steadily, like the quiet rhythm of nature. The collected latex is mixed with ammonia to keep it from coagulating, then transported to processing plants. There, it's concentrated, rolled thin, and dried into sheets of natural rubber. But for tire manufacturing, natural rubber alone isn't enough. To meet the demands of durability, abrasion resistance, and performance under harsh conditions, it's blended with synthetic rubber, a more stable material developed through petrochemical processes. Unlike natural rubber tapped from trees, synthetic rubber is created in labs through polymerization, a chemical reaction that links small molecules like butadiene, styrene, or isoprene, which are extracted from oil and natural gas. The result is a flexible, durable polymer that holds its shape even in extreme environments. Thanks to its superior strength, cold resistance, and wear performance, synthetic rubber makes up over 60% of the material in a modern tire. It's the core element that helps a tire deliver consistent performance over tens of thousands of kilometers. Most people don't realize that the deep black color of tires isn't natural at all. In fact, raw rubber is actually an off-white color. To create a material strong enough for automotive use, manufacturers blend a variety of ingredients. This mixture includes natural rubber, synthetic rubber, carbon black, softening oils, sulfur, and a range of specialized additives. In the mixing stage, more than 30 components are carefully measured and combined. Carbon black is added to improve durability and abrasion resistance. Softening oils help the rubber remain flexible and elastic across different temperatures. Other additives fine-tune the rubber's physical properties, from its melting point and curing time to its final hardness. Once the ingredients are ready, they're fed into a massive industrial mixer operating under high heat and pressure. Within minutes, everything is blended into a thick, jet black rubber compound. But it's more than just a mix. The additives interact on a molecular level, reinforcing the structure and making it far stronger. The compound is then flattened into thick sheets, rolled up, and sent to the cooling section. At this point, it still doesn't look like a tire, but the essential traits that define one, like durability, elasticity, and resistance to stress, are already being built into every layer. The process of building the core components of a tire begins with thick sheets of black rubber, carefully treated to ensure uniformity and mechanical strength. First, the rubber is passed through rollers to flatten it into thin layers, which are then wound up evenly. Technical systems behind the scenes make sure that no air bubbles or folds remain that could compromise the structure. In the next stage, a layer of high-strength synthetic fabric is coated with molten rubber on both sides. A heated calendering system applies controlled pressure and temperature to ensure the rubber bonds tightly and evenly to each reinforcing fiber. At the same time, ultrafine steel wires, thin but incredibly strong, are laid out in parallel alignment. These wires are bonded to the rubber using intense pressure, creating the tire's core structural frame. This reinforcement allows the tire to maintain its shape and perform reliably even at high speeds. The entire process is managed by advanced technology, where every detail is carefully monitored and adjusted. The result is a product that's not only durable, but also engineered for safety and consistent performance under a wide range of driving conditions. Once all the components are ready, from the airtight rubber layer to the precisely aligned reinforcement fabrics and steel belts, the shaping process begins. These elements are brought together to form the initial structure of the tire. On a large rotating metal drum, an automated assembly system kicks into action. Robotic arms move in sync, following pre-programmed instructions, executing each task with extreme precision. Every parameter, from rolling pressure to rotation speed and pressing time, is tightly controlled by a centralized digital system. With the capacity to assemble dozens of tires per hour, the entire setup must maintain tolerances within 0.1 millimeters, a near-perfect standard in the rubber manufacturing industry. Each rubber layer is applied to the drum by a servo-driven system, pressed tightly and aligned perfectly with the previous layers. To prevent overlap, misalignment, or wrinkling, force sensors work in tandem with industrial cameras to monitor every millimeter of the surface. Image and pressure data are processed in real time, allowing the system to instantly adjust the rotation, pressing force, and wrapping speed at each contact point. As soon as the raw structure is built, the next phase begins, inflating the tire body with compressed air. The internal pressure causes the soft rubber shell to expand and conform precisely to its intended shape. This marks the first transformation, from a collection of separate materials into a unified, cohesive form. Pressure sensors and shape scanners monitor every subtle change. If any deformation is detected, the system halts immediately for correction. In just a few seconds, the basic shape of the tire is complete. A raw but promising structure, ready for the next stage of transformation into a final product built for strength, precision, and endurance. In smaller-scale production lines, the tread, the patterned surface that makes contact with the road, is sometimes attached separately before the tire enters the heating phase. This process uses a cold pressing method, where the tread layer is pressed firmly onto the raw tire body using a flat press machine to ensure it's properly bonded before heat treatment begins. However, in larger and more advanced factories, the tread is formed directly during vulcanization, a process that's both more precise and cost-efficient. The entire tire assembly is placed into a two-piece metal mold, sealed tightly like a giant waffle iron. Inside the mold, intricate negative patterns define the exact design of the tread. Once the cycle begins, the system heats the mold to around 160 to 180 degrees. At the same time, compressed air or superheated fluid is pumped into a flexible bladder inside the tire, creating pressure that pushes outward. Under this force, the softened rubber expands and presses firmly into every fine groove of the mold, forming the final shape of the tread. The vulcanization process lasts between 10 and 15 minutes, depending on the tire's size and type. During this time, a chemical reaction takes place between the sulfur and the polymer chains in the rubber. Molecular bonds are reinforced and locked in place, transforming the rubber from a soft, moldable material into a tough, elastic structure. This stage plays a critical role in determining the tire's mechanical strength, heat resistance, road grip, and overall lifespan. Right after leaving the curing mold, while the tread is still warm, the tire is immediately sent to the quality inspection area. Here, it must pass a series of rigorous tests before being certified as road-ready. Though it may already look like a finished product, a tire isn't considered complete until it clears this final round of evaluations. The inspection process begins with geometric measurements. Industrial laser beams scan the entire surface to check the tire's roundness, center alignment, and thickness. Even the slightest deviation is enough to disqualify it from moving forward. Next, the tire is mounted onto a rotating spindle and inflated with compressed air at a pressure higher than its normal operating level. This test checks for air retention and structural integrity under stress. Any leaks or abnormal deformation are instantly flagged by the system. In more advanced facilities, X-ray technology is used to examine the internal structure, areas invisible to the naked eye. Misaligned layers, hidden separations, or bonding defects can be detected early with high precision. Only the tires that pass all these tests are marked with an approval stamp and moved to storage, ready to take on the road ahead, where speed, weight, and pressure demand nothing less than perfection. Every year, after traveling hundreds of thousands of kilometers, billions of tires are discarded, piling up in landfills or abandoned in nature. But unlike biodegradable materials, tires are nearly impossible to break down over time. They contain synthetic rubber, mineral oils, heavy metals, and other highly durable chemical compounds, all of which pose long-term risks to soil, water, and air quality. When burned in uncontrolled environments, tires can release toxic gases like dioxins and benzene. Left to degrade in the open, wind and rain can gradually wash microplastics into waterways, silently entering ecosystems and the food chain. To address this challenge, many countries are now using advanced recycling technologies to turn old tires into raw materials for new ones. Through a mechanical grinding process, waste tires are shredded into fine rubber granules, then treated with heat, pressure, and chemical additives to partially restore their original properties. This recycled rubber is typically used in the inner layers of new tires, such as the liner or cushion, where it doesn't come into direct contact with road surfaces. Though recycled material only accounts for 10 to 20% of each new tire, it represents a crucial shift, reducing dependence on petrochemical resources, cutting down waste, and gradually turning what was once an environmental burden into a sustainable, circular solution. Beneath what seems like a simple layer of rubber lies a complex chain of technologies, precise down to the smallest detail. It may be just one small part of a vehicle, but the tire is the only point of contact between a multi-ton machine and the road, the place where motion, safety, and performance all begin. We hope this video has given you a new perspective on something so common in daily life.